Okay. Yeah.
Okay, it's exactly time. Great. I love the hands I'm seeing. So let's start with Mariama Yakubu. Mariama. Mariama Yakubu. Hello, can you hear me?
Yes,
Yes,
please.
madam.
So why is somebody's hand up and the person is not here? Okay. It could be that it's the network. Godfred. Godfred.
Madam,
Yeah. Go ahead.
the answer is C.
And your reason?
Yeah, per definition for
So
fun.
T, meaning you are saying that, let me put what we are talking about on. Please hold on. Let me pick it
Okay.
up from the platform so that we can all see what we are talking about. If Godfred is saying C, it means that you are trying to tell us that I and I only are functions.
Yes, madam.
Grace, go ahead and justify
So
your reason.
the reason is that for the one as for function, each member in the domain should have one member in the codomain. So looking at I, please, madam, can you shift the image up? Thank you. Looking at I, we can see that the member in the domain, 1, 2, 3, they are having exactly one member in the codomain. 1 maps to A, 2 maps to A, and 3 maps to B. It means that each member is related to one member in the codomain. And when you come to the II, the members which are P, Q, and R in the domain is mapping to exactly one member in the domain. So as you can see, P is having only one member in the codomain, which is A. Q is also having only one member in the codomain, which is the same A, and R also having the same member, exactly one member in the codomain. So that's the reason why I'm saying I and II are they are all functions. And for the last one, the reason why the last one is not a
Mhm.
function is that we can see that Y is mapping to two members, which defines the concept of function. Thank you, madam.
Thank you very much. Please give it up to Secretary Godfred. Thank you very much, Godfred. So based on these three illustrations, which of the type of relations that we have learnt about would you say can be called or can be classified as a type of relation? Please let me show by hand before you answer. Among the four primary types of relations that we have learned, which of them would you say is a function and which of them would you say is not a function? Gifty.
Okay. So, one-to-one is a function. One-to-one relation is a function. And then many-to-one
Great.
relation is also a function.
No, come again. You said one-to-one is a function and what?
Many-to-one is also a function.
Great. So I believe it's clear. So one-to-one is a function and many-to-one. So if you are teaching the learners, let them establish this. It means that if I have a domain and in the domain there is no mapping in the codomain, I will not call that as a function. And that is why from the image, the C, even with the C or the III, you realize that the X and Y, the Y was having two mappings in the codomain, and that is what made it not a function. Any question? Please, I believe by now we all have a clearer idea of what a function is. Michael, your mic has been, you have unmuted. Do you have a question? If there's no question, then yes.
Hello, madam.
Go ahead.
So in this case, are we saying that, or can we say that a relation can be a function, but a function cannot be a relation?
Now to the class, what do you think? Can we say a relation is a function, but a function is not a relation?
Yes.
Yes.
No, madam.
But
All
not
functions are relations.
All,
All
not
functions are
all
relations.
relations are
no,
All
not
relations are functions.
Please,
but
no.
all functions are
one
relations.
after the other. So the functions that we have, all the functions, you realize that we have 2 or 4 primary types of relations. Out of these 4, only 2 can qualify to call what functions. So it means that the functions are subset of relations. Relations are not subset of the functions. Relations are the mother, then the functions become the children in the relation. I hope we have answered your question. But then what you should also take note is that all functions are mappings, because there is a rule that will be linking these functions to the other. So all functions are mappings because there's something that links them up. Okay, so for the sake of time, thank you very much. I believe those presenting can continue for us. We have come to know what a function is. So as we move on, the more they talk about what a function is, the more we have a clearer picture of it. So please, I will mute myself, then kindly go ahead with your functions. Group 5 members, please go ahead.
Hello, madam.
So take us through the 2 types of functions now.
Okay, with the types of functions, we have one-to-one function and many-to-one function. And the one-to-one function talks about, let's say, a function f of x. Before that, if a one-to-one function
Doctor, you are muted, we can't hear you.
madam, sorry. With a one-to-one function, a function f of x maps to y. It's a one-to-one function if different elements in set X have distinct images in set Y. Example of set, let's say set X, we have 2, 3, 4, and 5. Then
So
set
don't talk,
y.
don't talk about the one-to-one relation again of function. I think we've spoken enough about it. So please go ahead.
With the, I should stop with the example and move on.
Exactly what I said. We have said a lot about the proof, and we've done a lot of illustration for the
Okay.
one-to-one. Yeah, so move on.
So with a many-to-one, it involves where several elements in the domain have one image in the codomain, like the example that we gave. So my brother will talk about the standard notation using how to write functions using the standard notations.
Okay, I'll continue from writing function using standard notation. So when we say notations, they are simply standard ways of writing how inputs are related to output, or how relations are written. So if you see a function, what does these letters mean, or what do they represent? Madam, please, can we go to the board, please? Yes, so I have one. I have F is to A. Madam, F is to the semicolon symbol. F is to A. Yes. Capital A, capital A. Capital A maps to B. That is small arrow to B. Then B. And then you come down. F of X is equal to Y. Yes. So these are ways of representing a function. So here the F represents the function, the name of the function. So whenever you see F of A, F of B, that's the F there is the function. So F is not the only letter used in writing function. You can have other letters. So the F is the function. Then here the capital A is the domain. That is the set of all possible inputs. And then the B here is the codomain, which also represents the set of all possible outputs. So when we come down, so the F represents the function, and then the X here represents elements from the domain. And then the Y represent the image or output of X, another function. So the S here is the element that are found in the domain. So when you put any element that is in the domain into the function, you get a response, which is what? The Y. So here, F of S is equal to Y, simply means Y simply means the function F maps S to Y. So S to Y forms an ordered pairs. And this ordered pairs, it simply means that when you put an element in the domain, which is say X into the function, you get a response which will give you Y. So these forms ordered pairs in the function. I'm done. Please, can someone continue?
And who is that someone? It should definitely be somebody from your group. Please, group members, I've told you when you are coming, know who will pick it up from where. So thank you. So at this point, they have come to let us see various ways that functions can be represented. How do we present functions? I believe the most one that most of us are familiar with is the one where we see the semicolon, or the one that we see the brackets. I believe we are all familiar with that. So can you continue?
Madam, please, our group was the first 17 slides. So group 5, we are done for the presentation. The rest is for group 6.
The first 17, and we are on slide 8. So how can you say you are done?
Hey.
This is slide 9. So it means you are not done. Or?
The notation of functions is slide 10. Then we continue. Okay.
So you left all these ones. Okay.
No, madam.
You didn't look at how to check whether a mapping is a relation. It's also part of your slides. Very important point. You can't throw it away. So first of all, if we have a relation, please, if I give you slides, kindly check your slides and go exactly according to it. Don't take some off and present the one that you feel you want to present. If it's the first 17, then you have not even done 10. You just jump to the 10 because that is where your favorite. It is not right. How many are you in the group? You are many. I believe in every group. I'm getting more than 5 people in a group. I was even about
11.
telling you that you are too many.
11 in
So where
each
are the
group.
rest of the
If we
people?
are 10,
Please, and even if you are 10 and you have
Please,
17
you are,
slides,
each
how
group
can
is
you?
11, except group 2. It is only group 2 that is made up of 10 members. For the rest, we are 11 each.
Please, I take note of those who have been doing the presentation. If you are 11, how can only 3 people present and say you are done? Where are the rest of your people? Where are the rest of your members, please? Look at.
Madam.
Where are the rest?
Madam.
Okay.
Madam, I'll continue. Let me continue.
Isabel, please take note of those who are supposed to present, who are not presenting. I
I'll
need
do
that
that,
list.
I'll do that. Thank you.
Dorcas, go ahead. Before I come in, go ahead.
Okay, how we are identifying functions from relations. That is to determine if a relation is a function. We check that each input from the domain corresponds to one and only output in the codomain. If any input has multiple output, the relation cannot be classified as a function. Like the example that you gave us to solve, we need to check if a relation is a function. We need to check the domain. If the domain corresponds to one and only image in the codomain, it is a function. But if the input has multiple output, the relation cannot be classified as a function. Then we have examples of the non-function. How to determine that this function, this example is not a function. When you look at the pairs over there, we have 1, 2, 2, 4, 3, 5, and 2, 6. When we check the pairs over here, we can see that the 2 is mapping to both 4 and 6, which violate the definition of a function, because we know that the definition of a function states that each input in the domain is supposed to map to only one output in the codomain. So with this example, it is not a function. Yeah, then we move to the identifying functions. So with the example A, and so we move to the types. Madam, we have talked about the types of 1 to 1 and many to 1.
Let me add a small example to identify the deep mapping. Madam, please, can we go to the board?
Go ahead. I'm on here.
So we have two sets, domain and codomain. So the domain has elements 1, 2, and 3.
1, 2, and 3.
And then the codomain has A and B.
A, B.
A, B. So here one maps to A, and then 3 maps to B.
Okay.
So for this example, this is not a function. Why is it not a function? Although some of them follows the rule that each element in the domain must map to only one element in the codomain. But the key word here is each. So if you see 2 in the domain is not having any element it's not mapping or having any image in the codomain. So because 2 is not having any element in the codomain, it makes this function, it makes this relation not a function. That is another example that I wanted to add.
Okay, thank you very much. I think they've done very well. So we have all established that before I can call you a function, every item in the domain should be satisfied. How are you going to get your satisfaction? Is this by 1 to 1 or many to 1? If it is many to 1, then I can say that is fine. However, if you move to 1 to many or many to many, then it means that you are no more a function. Now, what's another name for 1-to-1 function? You didn't bring it up. That is also a very important point that we need to know, because it's something that sometimes we teach our students about 1-to-1 function, but they don't know that they can also call it what? The injective function. So injective function is another name for 1-to-1 function. We have already established it. We have seen a lot of examples with respect to that, whereby we are saying that with respect to the injective function, every pair has a distinct element in the domain. In the domain has its corresponding distinct image in the co-domain. So that is what we call the injective function. So another name for 1-to-1 is injective function. Then 1-to-many. I believe that one too, you have heard more than enough about 1-to-many. So when I come to your classroom, many-to-1 function. When I come to the classroom, how do we talk about many-to-1 function? Example is Muslim marriage. So let's assume that we have the wives in the domain mapping onto the husband. Then that becomes a what? A many-to-1 function. Please, you can be given a function and asked to prove whether that function is 1-to-1 or not. That is one of the examples you have to consider. So at this point, those who are supposed to pick the next slides will come in for us to see how they are going to pick this 1-to-1, for us to see whether the function we are giving is 1-to-1 or not. So the final group, what is the group?
Madam, please,
Group 7.
I want to find out something. Madam, please, this is Marian.
Mariam, please go ahead.
About the many-to-1 function.
Yeah,
Can we cite an example like in the class, let's say basic eight students all mapping to their math teacher as
Yeah.
one.
Yeah, so far as the teachers are the students are in the domain to the teacher, then that
Yes,
is it.
the students are the domain, then the teacher is the
Yeah.
co-domain. Okay.
Yeah,
All right, thank
great. So now the final group, please. We have 30 minutes. The final group.
Okay, Madam, group
If you are
6.
group 6. So I'm muting myself. Group 6 members, please take the floor.
Okay, so we are starting from how to prove one.
Hello, madam. Madam, before group 6, we still have group 7 before the other group.
I don't understand.
We have 7 groups, madam, and currently group 6 are doing the presentation. So we still have our group 7 to do.
And that's what I'm saying, that if they are done and it's time, we'll move it to Tuesday. That's what I said.
Very well.
Godfred, please go ahead.
Okay, Madam, thank you. So we are going to prove 1-to-1 functions. So before we start proving, I think group 6 has already taken us through the definition of 1-to-1 functions. So we'll quickly move to how to prove the 1-to-1 functions. Now we are saying that s power 2 or s exponent 2 is not 1-to-1 functions. Why are we saying that? Now, for a function to be a 1-to-1 function, then it means that the members in the domain should have exactly one member in the codomain, or a range should have at most one member in the domain. So for example, if we pick 2 domains and we substitute into the function, which is f of x is equal to s squared. For example, if we have 1 positive 1 exponent 2, we will get 1. And a function of negative 1 exponent 2, we also get the same answer as 1. Here, the range, which is 1, 1, is both ranges are having one corresponding member in the codomain. For clarity, let me use 2. Positive 2 and negative 2. A function of positive 2, when you set it into the function, you get 2 exponent 2, which will give you positive 4. When you also substitute negative 2 into the function, you also get the same positive 4. It means that the range here is getting one member in the codomain, which defies or violates the principle of one-to-one functions. Thank you, madam. Someone will continue from.
I would have loved it if this is very well illustrated. So, Isa, please, I say, Isa, Fetcher, go ahead and
Madam.
let's go through the illustration. The illustration will let us get the picture clearer. So we are using the rule f of x is equal to x squared. So how do we go about it? So we have 1 here. We have 2 here, then we have negative 2, right? So from 1, we can have 1. Negative 2, we have 4. So what is happening is that 1 is mapping onto 1, which is fine. 2 square will give you 2. At the same time, negative 2 square is also giving you 4. So you realize that 2 of the items here are mapping onto 1 element. And that is refuting our rule for which. So in that case, it means that we can draw the conclusion that x squared function. Please, it's a function, but it is not 1-to-1 because we didn't get. Joshua, please mute yourself. Joshua, mute yourself. Thank you. We didn't get distinct elements in the domain mapping onto distinct elements in the codomain. So that is why we say that it is not a 1-to-1 function. However, it's a function, but it's not 1-to-1. Thank you very much. Please go ahead to the next one. Who is next to take up the other examples? We have x raised to the power 3, 2x plus 1. So take us through and let us see why these ones are 1-to-1 and the other example wasn't. Please, you are wasting time. Let's be snappy.
No.
So I think someone will take.
Please, it's okay. Mute yourself and let another person take over.
For f of s equals to s cubed, if you have to replace negative 2, you will get negative 2 raised to the power 3. And that will give you negative 2 times negative 2 times negative 2, giving you negative 8. So get it, and then f of 2 will also give you positive 8. So that is 2 raised to the power 3, giving you positive 8. So getting positive 8 for f of 2, and then getting negative 8 for f of negative 2, that function is 1-to-1 function. Because for 2 raised to the power 3 will give you 8. And the negative 2 raised to the power 3 will also give you negative 8. So once you are getting these two different answers, we can say it is 1-to-1 function.
Excellent.
Now,
so negative 8 and positive 8 are distinct answers.
Yes.
So negative 8 will be for negative 2. Positive 8 will be for 2. Positive 2. So it means that they are distinct answers. It's not like the first one that we found that it was mapping onto the same 4. So that is the difference. Kweku, please continue.
Yeah, when it comes to f of x equals to 2x plus 1.
Hold on,
now let's
hold on and let me write.
f of s equals to 2s plus 1. If you pick f of 1, that is 2 into 1 plus this one will give you 3. And if you pick f of 2, that one will give you 2 times 2 plus 1, giving you 5. And when you continue further, f of 3 will also give you 7. So it means that each input is giving you a distinct output. So that function too is one-to-one function.
Excellent. So you realize that as I keep on changing the value of the x, because I'm multiplying by 2 and I'm adding 1, it will all take up distinct values of x are going to take on distinct values in the domain, in the codomain, because every input of x that I'll place, I'm going to get different answers for that. So I believe it is clear. We can prove which one is a function and which one is one-to-one and which one is not one-to-one. How do we do the proving? We have established that it is based on the solution. If you realize that one answer is being mapped onto by a same thing in the domain, it means that you are becoming many to one. The moment you become many to one, you do not fall into the category of one-to-one. So we are going to rule you out. Are we fine? Please, reaction, please. Reaction. These are some of the possible questions you should expect in examination, whereby you can be asked to prove whether the function is one-to-one or not. So on your own, I believe most of us are teachers. You can pick questions and be trying your hands on them to see which one is a function and which one is not. Please, group 6 members, continue.
Now, coming back to the proof again. If a function is one-to-one, then f of x must be equal to f of y. So now let's pick a function like f of s equals to 1 on 2s minus 3. Madam, can you assist me on the board? F of s equals to 1 on 2x minus 3. So for this, no, 1 all over 2x minus 3 is 1 all over 2x minus 3. But 1 all over 2x minus 3. Two x minus 3. Thank you. So if we are to prove for this, it means that f of x is supposed to be equal to f of y. F of s equals to f of y. And this implies that s will be equals to y. So we go back to the function and then replace both x and then y and check. So the first one, we have the x 1 over 2x minus 3. Let's use for y, f of y. And that will give us 1 over 2y minus 3. So when you equate both, equate the two. So we are equating the two, 1 over 2s minus 3 and then 1 over 2y minus 3. So when you do the cross multiplication, we will come to realize that s will be equal to y. And hence, we can say that the function f of s over 1 over 2s minus 3 is one-to-one function. Now, again, we can also prove for j of x equals to 2s minus 1.
So because of time, thank you very much. Thank you. Because of
All
time,
right.
so that you can conclude with your slides. So please
All right.
continue with your slides. Yeah. So
Now
you have
we
other
have,
things to talk about in your
yeah,
slides. So
even
go
and then
ahead.
odd function.
Yes, go ahead to that.
A function f is said to be an even if f of x is equal to f of negative x.
So hold
Now
on and let me write that. So if f of x
is equal
is
to
equal to
f of negative
f of
x,
negative x, then we say the function is what?
an
Even.
even function.
Yeah.
And most of the time, all the even functions, their powers are even numbers, and they are symmetrical around the y-axis.
How's this? Okay.
So now let's pick a function. J of x equals x raised to the power 5 minus x raised to the power 5 minus x raised to the power 3 all over x. Now, if you are to prove this, it means that for j of x and then j of negative x is supposed to give us the same thing.
Okay.
So we prove for j of negative x. So negative x raised to the power 5 minus negative x raised to the power 3 all over x.
Why are you not bringing the negative for the x?
Yeah, the x will contain negative all over negative x. X will contain. So negative x raised to the power 5 will give you negative 5x, negative 5 raised to the power 5. Negative x raised to the power 5. Negative x raised to the power 5. And then minus negative x raised to the power 3. That one will also give you negative. So the negative will come and then make the minus sign positive. So that there we have negative x raised to the power 5 plus x raised to the power 3.
Okay, plus x raised to the power 3.
X raised to the power 3. All over negative x. So if you have to use the negative x to cancel to divide, you see that the negative will cancel the negative in front of the x raised to the power 5.
So hold on. So negative x raised to the power 5 plus x raised to the power 3 all over negative x.
All over negative. So we use the negative down to divide and then x raised to the power 3 will also be negative. So we come back to the original thing.
Okay. So it means that j of f of x will be equal to g of x. And that makes us see that. So what's the conclusion that you are drawing here?
So since g of negative x is equal to g of x, the function is an even function.
Great. So what are we saying about even functions? What we are saying is that if you are even,
please, madam, I
then
have a question.
Yeah, go ahead.
Please, madam, I have a question.
Daniel,
The
go
g
ahead.
of x, please, madam, the g of x, it is x minus x exponent 5 minus x exponent 3 all over x. If you compare it to
what I have, hold on. I've gotten what you are saying. I just skipped the step. That's why I thought everybody has seen it. So over x. So when you pick the first one, this negative over x is affecting all of them.
Yes. Madam, so with the top one, you need to factorize it out. The negative.
Factorize it out how?
Like it will be
if
negative.
Breaking...
It will be negative x exponent 5 minus x exponent. Madam, it will be negative into bracket.
Why do you want to factorize? Hold on. Why do you want to factorize it out?
Please, madam, if he does it like this, it won't be equal to the j of x.
Okay, so you go ahead and let me see what you're saying.
So, madam, it will be equal to minus or negative into bracket into bracket x exponent 5 minus x exponent 3 bracket close all over negative x. Then the negative will cancel the negative so that the x gain of x will be equal to the gain of negative x.
Okay.
It's the same thing. It's the same thing.
So good. Do you get what he said? So
Yeah,
he was
I
dividing
understand.
through by the negative straight
Yes.
away, but it's the
Yeah.
same thing as what
You
you
can
have
do the
said.
factorization and then.
Yeah, it's the
All
same
right.
thing. He said when you divide through by the negative, I think it's the same thing. So
Yeah.
I think the point is clear. What are we establishing with respect to even numbers? If I pick you and you are even, when your function is odd, whatever solution I got or whatever that I got from your function being positive, the same thing should happen if I negate your function. If I negate your function and your result is different from the result when you were positive, then it means that you are not an even function. That is the point that we want to establish. Later on, as part of the work that I gave you, I'll give you some functions that you check, you prove whether they are even or odd. So you add it to the trial questions that we'll be doing later within the week when we are done with the presentations. Any question at this point with respect to even and odd, with respect to functions so far? If there's no question, we have some few minutes to go. Please continue with your presentation so that we can conclude.
Yeah, we are.
Now
we
know
are
what even functions are. Let's go on to odd functions.
odd function. A function
Characteristics
is
of even
said to be.
functions. Please hold on. You have made mention of characteristics of even functions already. Please do not rule some of these things out. These are the possible questions you can get in objectives. So what we are saying is that an even function is symmetrical about the y-axis. That means that for every x value, it has a corresponding what? Y value, which is equal to that of what? The negative x, because we said that the positive values are equal to the negative x values. And that is what we are saying about even functions. And what this property does is that it allows even functions to have what? Consistent output for both positive and what? And negative input. So if I have positive output, I will see my results. The same thing applies to if I negate it. And we are also told that common forms of even functions include polynomial functions with even powers. So if you have a polynomial function, I believe you know what polynomial functions are, and the powers are even. You know what even is? It means that automatically that function is going to be an even function. So please take us through odd functions.
Now, odd functions. So, if you consider f of x, madam, assist me with the writing. F of x is equal to negative minus f of negative x, or minus f of x is equal to f of negative x. And then odd functions too, they also have a powers which are odd. For example, f of x equals to x squared. So for this, if you have to replace x in the equation and then simplify the equation we wrote earlier, if you take minus f of x squared, minus x squared, that one will also be the same as negating. Please, madam.
Come again. Yeah,
We
come
are
again. I didn't
taking,
hear what you said.
yes, I said f of x equals to x squared.
Mm-hmm.
So now we are having a power which is uneven. We are going back to the
Mm-hmm.
equation and then place x and see what will happen to the x squared. Whether the
Mm-hmm.
equation written earlier will satisfy f of x equals to x squared.
Mm-hmm.
So we are taking the second one, negative f of x
Mm-hmm.
equals to
Mm-hmm.
f of negative x. So here it means that when you square x and then you put negative in front, it's the same as squaring the negative x
Kweku, your line is breaking on.
Oh, sorry. My network is very bad. Please, one
Sorry.
of the members should continue.
Okay. Any member from the group to take it through all functions so that we can conclude peacefully? There's a hand that has been up for a while. Who is that? Do you have any question to add? To ask? Mm-hmm. Where are the members of this group?
Madam, please, we are here.
I'm listening to you.
Okay, please, madam.
Conclude
When we
it
talk of,
nicely so that I can come in. Yeah. Just the odd functions, then I can come in, then we'll close.
please, can you hear me?
Yeah, Joshua, we can hear you. Go ahead.
So we are saying that the odd function it satisfies the property that f of negative x is equal to negative f of x, as my brother was saying. So we are saying that the odd functions are rotationally symmetrical. They are rotationally symmetrical, which means that if you rotate it 180 degrees, if you rotate the function 180 degrees, it will be the same as, please, can you hear me? Please,
I can hear you. Please go ahead.
we are
So
saying
thank
that
you
if
very
you
much.
rotate,
Joshua, hurry up and conclude and let me come in.
so in conclusion, what
Okay,
I'm saying is
Joshua,
odd
we are not hearing
functions,
you well.
they
It's
have,
okay. It's okay. What you are saying is, I say meet yourself. Thank you. So your line is breaking. This is what we are going to do. Please kindly go online now, just as you did for the the function. What is the difference between odd functions and even functions? With examples. So I'm waiting. We should use ICT in our classroom. So let's start using it now. What is the difference between odd functions and even functions? With examples, type it like that. So as we are concluding, I want to hear responses from members before we go, so that I'll know that nobody left us alone. I know you have not left us, you are with us. So let's do this and conclude. What is the difference between even functions and odd functions with examples? If you have been raising your hand and I don't call, please, there is the time for me to call you. Difference between odd functions and even functions. With examples, then that will be the recap for the day that we can conclude. Yeah, Isa. Oh, it's not, is it not Isa? Jacob. Jacob, your hand is up. Or is that not Jacob?
It's an old hand. I'm not searching.
Okay, great. So if you know your hand is you raise your hand for an old hand, kindly lower your hand. So just 3 minutes. Difference between odd function and even function. With example, then we can conclude.
The main difference is how a function's output changes when each input is negated. An even function satisfies f of negative x equals f of x, meaning each value is unchanged with x and negative x. Each value is suitable.
Yakubu, we can hear
Hello,
you.
madam. Okay. So, per my checks.
Are you ready?
Yes, I'm
Okay,
ready,
pay your
madam.
checks. Go ahead. Go ahead.
The main difference is how a function's output changes when its input is negated. So here they are saying an even function satisfies f of negative x equal to f of x, meaning can I continue?
Please continue.
Hello?
Sorry.
Okay.
Yeah, Yakubu, please continue.
Okay, madam. So I'm saying an even function satisfies f of negative x equal to f of x, meaning its value is unchanged for f, is unchanged for x and negative x, and its graph is symmetric across the y-axis. So for the odd function, an odd function satisfies f of negative x and f of is equal to negative f of x. So its value is negative.
Okay. Thank you very much, Yakubu. Thank you. We got it. Thank you. Allow other people to come in. Yes, any other? Yakubu, thank you very much. So it's about the output. Thank you very much. Any other? Any other person? Any other person with respect to what an odd function is? Okay, so I'm getting some hands here.
Please, madam, can
Sharif,
I talk?
Joshua, I call Sharif.
Yeah,
Let
madam.
Sharif come in before. Yeah.
Yeah. So it's just the same as Yakubu's one, but the addition I also make is that if you replace x with a negative number to make it negative x, and the sign remains unchanged, that means the output remains the same. That means it is even. And then for the odd functions, when you replace, yeah, for the odd, if you replace the x with a negative, the function will change. That means the signs will not be the same again. So that makes it odd. That means they are symmetric about the origin. So it will change.
Excellent. Thank you very much. Any other? Joshua, last one.
Joshua. Hello, madam.
Hello, madam. So what I wanted to add to the odd is what my brother said. The signs, if the domain is positive, the codomain, the codomain will be negative. But if it is negative, it will change to positive. So that is what the odd functions is talking about. And when you talk of the even functions to, if irrespective of the sign, if it is even or odd, it will result the same value in the codomain. Like when we have a function f of x is equal to s squared, if we substitute, if x is equal to 1, the answer will be the corresponding codomain will be 1. But if you say, if we substitute negative 1, its corresponding value will be the same as 1. So negative 1 squared, all squared is equal to 1, and 1 squared, we have the same 1. So that function is an even function. But when we take when we talk of odd functions, they have a power of odd numbers, or they assume odd powers. So we can have a function having a power of 3, a power of 5, a power of 7. They are all odd functions.
Okay, thank you very much. So Now, the last example that we will talk about with respect to the odd functions is what I've illustrated beautifully here. So whenever we talk about odd functions, the conclusion that we can draw based on whatever we've said is that if the function, we have a function f of x is equal to x, if this function f of negative x, that is, if you negate the function, is the same as negative f of x, then it means that that function can be classified or can be called an odd function. So I have an example. Let's assume that in this example, I have f of x to be raised to the power positive 3. I have x of x to raised to the power positive 3. You can be asked to check whether this function is odd or even. For it to be odd, I realize that the power raised to the power 3. So let me try by proving with the odd function. And the odd function says that f of negative x should be the same as negative f of the x. So for a start, I have f of negative x raised to the power 3. What is this going to give me? This is going to give me what? Negative f of x. And what is the f of x? Sorry, f of negative x raised to the power 3 will give me what? Negative f, or I can write it without a negative as f of neg x raised to the power 3. X raised to the power 3. If I want to bring the negative sign outside, then I'm going to get negative f into bracket what? X raised to the power 3. So I'm going to get negative f into brackets x raised to the power what? Positive 3. And this happens to be the original function that I was given. So it means that then f of x is equal to negative f raised to the power x raised to the power 3. And this is when I can say that the function is odd. So please, in the slides, we have some examples here that you can use to tell whether it is odd or it is not odd. So in conclusion, what are we taking away? What we are taking away is that we have come to see that when it comes to functions, we can tell that there are two main types of relations that we can classify as functions. We have proven what makes a function one-to-one, the same way that we have also proven what an even function is and what an odd function is. We have also done through examples what a function is not and what a function is. Great. Any question? Any question at this point? Please, from the ones that you are supposed to, the work that you are supposed to do, the examples I gave you that you'll be presenting, I'll be adding some of these ones to it just to help you practice. So it is all towards practice, just to prepare you for the exam. So I think we can end here. If there's no question, any confusion, any contribution, thumbs up and well done to all those who came in to contribute and present. To those who are not presenting, Isa, please let me have their names. Jacob.
Yeah,
We are
madam.
meeting on Tuesday at 6:30 to continue with the next slide. Yeah, Jacob.
Yeah, madam, my question is, you were advising that as we have been enrolled in this course, we should get some Aquila books. My question is, I know there are some variations in elective maths and core maths when it comes to the methods and then the way of calculation. So in this respect, which of them are we to focus our attention on? Is it elective maths or core maths?
Oh, but there's nothing wrong with you getting both of them. What do you think? It depends
I want to
on
know
what you want to go to the. No, it depends on which of these two you want to go to the secondary school to go and teach as an individual. And you can get some of the commerce items in the UMass. And it also depends on the topic we are considering. So you pick the syllabus and look at the topics that you have the course outline. So when you pick the syllabus, check which of them would can be seen in the UMass or the commerce. But I would advise you get to you're a math teacher. Maybe you might go and they say, we need a UMass teacher, come and teach. We need a commerce teacher, come and teach. So you should not limit yourself to one. Mathematics is mathematics. So you can get both of them. Then so that everywhere they take you, you'll be able to fit in. Have I answered you? Sheriff. Yeah, Sharif.
Okay, thank
So
you.
do not limit yourself to one. Great. Sharif.
Yes, madam.
Yeah, your hand is up.
Yeah, I have a question. Last week, I'm part of the group one, but I wasn't present during the presentation. So I was told that I will join group eight, so that we'll do our presentation different. I don't
So
know
go
if
and
we
join
are
group
part of
6.
it.
That is not up to us to decide you. Oh,
Okay. Okay.
yeah. So Sharif, that one is for you and your group 6 members. So look for them on the platform. Try and get their contacts and get in touch with them. Are you fine with that?
Yes, madam. Thank you.
Great. So since Sharif is fine, I believe everybody is fine. So we can conclude here. God willing, on Tuesday at 6:30, we'll meet for the other group members to continue. Please, I don't want you to come and say who is continue. One member in the group should continue. No. Let me see that the coordination between you and your members are very, very strong. Yeah, that is what I want to see. Kweku, Boama, and Jacob, then we can conclude.
Hello. Yeah, madam, it seems today the participants are very few, up to somewhere 40, but we are more than that. I don't know whether different centers were having face to face. That's why they couldn't join. Or
No, I can't tell you. The point is, I understand some people came to join online. Maureen, you are laughing. I'm lying. I can't tell. I don't know what's going on. What I know is that some people were not supposed to join online, but they came to join online. Mostly what happens is the moment you start online teaching, a lot of people feel lazy to go to their various centers. So they rush to come and join online. But the moment they realize that we are about to end with the block and maybe assessment to come in, then they'll go back to their original places. So do not be afraid.
so
Allah
could
is
it be
with us.
possible that the members assigned to the various groups, some are not actually on online?
I can't tell, but that's what I'm saying.
Okay.
That is why I placed the other time. Hold on, that's why. Hold on. That's why the other time I placed it on a platform that I want attendance or names of those who are strictly online. So that will help me fish out those who are not online. From now until the list is ready, I can't tell. Maybe you cry, you are not online,
Madam,
but I can't tell.
In our group, some of our members are not online.
Yes.
They are
So
not on.
the instruction is if you are not for online, don't be here. Otherwise, it
madam,
even disturbs our network. Yes, go ahead.
madam. Please. The last time, me for instance, my center is Kumasi West School, but due to where I was posted, now it's about 8 hours by road to Kumasi. So the last time I contacted the switch monitor and he said, "Oh, I can join the online classes. So when it's time for quiz and then exams, then I'll go to Kumasi and then write." So
No
that's why I
problem.
joined the online. Yeah.
I hear you.
Okay.
Yeah. Kwegu's concern was that the number was low. So
Thank
Kwegu,
you.
the point is that is how it starts. You see, when you start another block, they will be running and coming on like giddy giddy. The moment the block is about to end, then they will vanish. But it's fine. So thank you all very much. I think we can close here. Thank you all. Enjoy your day.
Mama. Oh, I found them.